Welcome Algebra 2. Today we're going to be going over how to solve and evaluate when you're looking at a graph like the one that you see here to our left. Alright, so if you look at this situation right here, f of negative 2, remember that when we talked about function notation, if we have an equation like this, f of x equals 2x plus 3, let's say that. Okay. If I have f of negative 2, what will we do with this negative 2? Well, this is our input. So we're going to plug that in for our x. So we're going to get 2 times negative 2 plus 3. This is our input. We're plugging that in for x, all right? And so we get negative 4 plus 3 is equal to negative 1, okay? So if we look over here, it's the exact same thing. F of negative 2, well, I just told you that's our input. That's our x value. If we're going to be using this graph right here, then we're going to have to look and see, well, when is x negative 2? Well, x is negative 2 right there. So when x is negative 2, what is my output? Well, my output is right there. It's in this little value right there. When x is negative 2, I just kind of go up, and once I get to it right there, I could see it. That looks to be approximately, if I put a little dot there, 2.1. So this is going to be 2.1. Okay. Similarly, if I look over here, f of 1, that's when my x value is 1. So when my input is 1, so if I look at my graph, when my input is 1, right over here, what's my y value? Well, this dot right there shows us that when x is 1, my y value is 0. Okay? Similarly, I look over at this one here. When x is 4, when my input is 4, what's my output? Well, when x is 4, it's right there, so we go up, and my y value there is 2. Alright, so that's how we go about solving this. It's not that difficult. It's essentially just, if this is our input, that's the x value, this is our y value. If x is our input, what is our y value? Okay, now if we go over to this question here, if we go over to this question over here, find x when f of x equals 1.5. Well, in this case, do we know what our input is? No, we don't tell you what's the number inside our f of our function notation or inside this parentheses. We're actually trying to find x when f of x equals 1.5. Another way of writing this is, what is x when y equals 1.5? F of x is the exact same thing as y. So if I look over here, right in this area is where my y value is 1.5. So now I'm going to look at my graph, my function, and see where on this function is my x value is 1.5. So if I look here, when y is 1.5, if I keep going, right here at this point, at x equals negative 1, my y value is 1.5, which is what I was looking for. And so one of my answers is going to be x equals negative 1. So when my y value is 1.5, which is right there, one of my solutions is at this point right here, in this little area, and my x value there is negative 1. Alright, now my question is there another point that allows that to happen? Well, when y is 1.5, here was one point where we got negative 1. Well, let's just keep going in this direction. If we keep going, there's a point right there. At this point here, what is that x value? Looks to be about 3.5. So, and 3.5. Okay? So at 3.5, my y value is 1.5. At negative 1, my y value is 1.5. And that makes sense because I was trying to find the x values when my f of x, which is y, when my y value was 1.5. So that's how we go about solving this. I hope that goes to clarify the difference between a number inside our parentheses, like this problem here, versus a problem when I'm giving you the output, the y value there. All right, thank you very much.